Hello, everyone, and welcome to our third installment of DDN's Ask the Experts Roundtable series. Today, we're diving into a very interesting topic for AI infrastructure leaders. It's called Truth in Numbers, the benchmarks that actually matter for AI and HPC. I'm Jason Brown, Senior Director of Product Marketing here at DDN, and I'm really excited to be joined by today's experts, Joel and Louis, as we dive into this thought-provoking topic. Because when it comes to AI and HPC infrastructure, performance claims are everywhere, but how do you separate marketing from reality? So before we begin, I'd love for our experts to introduce themselves. So Joel, why don't you start?
Sure. Hi, I'm Joel Kaufman. I'm an outbound product manager here at DDN. I have a wide range of experience in the industry working with a lot of storage companies over the years. I used to deal with HPC back in, if anyone remembers Silicon Graphics, I was there for a while doing all of that type of work and so on. And I'm glad to be here today to talk about benchmarking.
And we're glad that you're here. Louis, do you mind introducing yourself as well?
Yeah, sure. Hi, I'm Louis Dorier, and I work at DDN as a solution engineer, and I have a lot of expertise on all of our AI products and also all the solution we provide for AI.
Awesome. Well, thank you both for taking the time to join us today on this Ask the Experts roundtable discussion around third-party benchmarking. And so let's get into it. So first off, let's just discuss, why do customers care about benchmarks? Why do we do these things? And why is it important to participate in these things?
Sure. I'll take that one as a starting point. So when I take a look at benchmarking, there's really a couple of big things that are going on. You have customers that want to use sets of tools that are commonly available, things like VD Bench, things like FIO, stuff like that. They want to do just like a basic validation of maybe something they have. They want to test, does hardware get somewhere close to a theoretical limit? Do they want to compare, a pre-existing system to a new system around, maybe something typical, what they call a four corners type of just basic IO benchmark? And those are lovely and wonderful, but what we find is that customers really want to look at a couple things. They either want to validate an environment that they have and verify that it does things. And so there's a variety of different types of benchmarks you can use. Or they also want to say, I don't want to be the first one to have done this. I want an idea that if I'm going to go and build a system or buy a system, does it behave and meet up to a certain performance expectation that I'm used to or that I think it will get? And where can I find the research that says, here's what someone else has done, or here's what a vendor has done to get it into that realm that says, this is a reasonable solution for me, it meets my needs. And that's why I want to look at this particular configuration and get it going. So benchmarks that provide that type of information are actually quite valuable to a lot of customers.
I agree. Louis, what do you think about that?
Yeah, I definitely agree with what Joel just said. One of the good things with benchmarks is that it provides numbers, and these numbers can be used by all the customers to select rationally which system would do better on a specific dimension they are interested in. For example, this is a reason why we have many benchmarks, because there are many dimensions to measure on a storage system. So thanks to having these benchmarks, then you can see through the smoke and mirrors and see what's real and what's marketing.
It is. And just to give you a little follow-up on that, one of the things that we've also noticed, and customers, they see through this all the time, is if you put a number out there, it better be an explainable number and a repeatable number. And what that means is that, the old saying, there are lies, damn lies, and then there's benchmarks or statistics. Take your pick of whatever the end is, right? But if you just throw a number out there, you better be able to show how you achieve that number. And so you'll find that there's a difference between what we generally are called certified or verified benchmarks, ones that have disclosures around everything about how it was built, how it was run, etc., in order to say this is a provable, repeatable thing, versus just a general, like I mentioned those tools earlier, like you can run FIO or LBencho or VD Bench. You can tweak that to get kind of, in many cases, almost any number you want or a really optimized one, but it's not necessarily repeatable for a customer environment. And so making sure you have that validation and that transparency and disclosure of how it was built is really important as part of that.
Yeah, I agree. The transparency is super critical because we're in the AI HPC space. Performance is important. So numbers are getting thrown out all the time. And if there's a way to use a standardized way to at least try to do apples to apples comparisons, but it's not always the case. As if you dive into the details and that transparency, why that transparency is important, right? Sometimes we find that things aren't apples to apples, but more apples to oranges. But at least you still have that level of transparency that you may not have had if marketing was talking to you. So very important. And recently we found that there are two benchmarks which are very relevant in our space, the HPC and AI infrastructure space that DDN is a part of. The first one is IO500, and the second one is MLPerf. So let's start with the first one, IO500. What is it? What does it measure? Who submits to it? Why is it important? Joel, why don't you take the first lead there?
Sure. Yeah. So the IO500 has long been this very strong HPC centric type of benchmark. And it's actually becoming more important than just HPC moving forward, because as we're seeing, traditional HPC environments are beginning to transition into running AI types of workloads. And so people wanting to use that same set of configurations that they already have and get an outcome that's, again, similar that could be applied to an AI environment is actually pretty important. Now, the IO500 has a really storied history a little bit. For years, they would update it every year at an event called Supercompute. And so there would be Supercompute in the spring, and then International Supercompute, and they'd have a version of the benchmark that they would run. And every 6 months, it would slightly change. It was kind of hard to get some comparisons. But in 2023, I think it was 2 years ago, they actually did something that was really interesting. They switched from being this very open and sort of, you didn't have to submit every detail of the system, into they created a new category called the production category. And the production category actually has a couple of different things. It has what's called a reproducibility score. And you're either highly reproducible, partially reproducible, or you're not. And frankly, no one ever submits one that says we're not reproducible into that environment. But what it does is it gives a much higher level of disclosure. And so again, that confidence of saying, oh, I see exactly how they built the system to get the answer that we were looking for. Here's the clients that were used. Here's the storage that was used, et cetera. And so it gives a really strong indication that this is truly a production system using the exact components that you can get, and here's the configuration that put it all together. And I think we're really happy because at DDN, we wound up in a situation this last year that our customers submitted a whole bunch of production results into the environment. And correct me if I'm wrong, Jason, because I'm not on the marketing team anymore, but if I looked at the list lately, 7 out of the top 10 are DDN right now.
Correct. Yeah.
Is that correct?
Look at the 10 node production category, and there's 4 or 5 different categories across it. DDN does have 7 of the top 10 spots. And the important thing you said, though, this was customer submitted. We did not submit them. DDN did not submit them, which is different from other benchmarks. And we'll talk about the MLPerf one in a minute. But IO500 actually is submitted by customers, by actual companies running these things in production or in tests, because I believe there's like a test category as well, or open category, right? So like
open category,
that's super important to note. And obviously, we're very happy with the submissions from our customers and really thankful that they did that, because as you can see, for 10 node production systems, for HPC and of course AI as well, DDN does perform really well.
Yeah. And so just to give a little bit of transparency here, right? We're not, our customers do talk to us. Right. We know that they're probably going to, sometimes we know that they're going to submit, and we do help them. Right. I mean, but every vendor does that. It's not an out of bounds thing. Right. We want them to optimize their environment for what they're going to do. And the great thing is, because they're using all those production types of things, they're able to test out all the different types of components and everything else. Now, I think you asked me the question a little bit earlier, and let me give just a little more detail in terms of, what does the IO500 actually test out? It does a couple of things. It does single-threaded and multi-threaded workloads. It does a variance between heavy metadata testing for reads and writes and heavy types of throughput functions. And then it blends it all together to a certain extent, to the point where, and this is an interesting thing about the IO500, it's not linear. What it means is that if you get a result at a point and then you say, I'm going to throw twice as much networking or twice as much hardware at it, I should get twice the end result of the final aggregated number, the answer is probably not. There is a lot of variance in terms of what it does when it goes back and forth. And so I think it's important to get a lot of data points on the spectrum. So having 7 of the top 10, it's interesting because now you have different sizes of environments. While you have the same number of clients, the 10 maximum, the production 10 node, you may have had different backend storage. And so this gives you an idea about if you have a storage package that's this big, here's what your general result will be. If you had a storage package, much larger, then here's what that potential nonlinear result is. So instead of just getting 1 or 2 data points, you now have this wide spectrum, and you can actually begin to plot what that performance trend will look like based on what you want to get in your environment.
Yeah, absolutely, absolutely. Lou, I heard you wanted to jump in there. What are your thoughts here on IO500?
Yeah, as Joel mentioned, like we captured 7 of the 10 of the top 10 spots for the 10 nodes production list. And what's important also is to mention that this is the most difficult test for IO500. So this is one that is normalized by 10 nodes. So it gives you have to be good to achieve these numbers. And also, when you compare our numbers with our competitors, the difference is huge. Like the gap in performance is not small. There is like a 3x and up to 11x performance gap between what we achieved in this production list compared to our competitors. And this is for all workloads. This is for metadata, this is for IOPS, and this is for the throughputs.
Yeah, that's a great point. Obviously, it's a competitive market, and to see us have anywhere from 3x to 11x better performance in some of these various categories and components that both of you have mentioned it's extraordinary. And so we're obviously very proud of that and very thankful to our customers who continue to push the envelope for these great performance results. So thank you so much for that. I want to skip to the other benchmark now, the MLPerf one. Louis, I'll let you take this one. What is MLPerf? What does it measure? Who submits to it? Why is it important? Give us all the details on MLPerf.
Yeah, sure. So MLPerf, so we are talking about MLPerf storage, which is a specific category for in the like ML commands has many benchmarks, and MLPerf storage is a new category that they started a few years ago, and they provide a synthetic benchmark suite. And the main goal of this benchmark really is to provide something that is standardized, that is comprehensive, and that is realistic, and that measure the storage performance for AI workloads. So a key element really of this benchmark is that it's able to simulate the GPU behaviors for training workloads. So they had done a lot of work to achieve that. They had to measure a real workload, a real training workload, and see how fast the GPUs were. And they had to extract that number, how long it takes on a real GPU. And they had to put this number into their benchmark suits. So with all of that, it makes it possible to simulate a real training workload on any number of nodes and using any number of GPUs per node, and to measure what would be the storage performance. So it's scalable, it's realistic, as I mentioned, and it measures storage performance. And also something to say is that it's using real AI frameworks. So yeah, it uses PyTorch and TensorFlow. So it's a realistic simulation of an AI training job. And the question it tries to answer, like what is the number at the end of this benchmark, is how many GPUs can you feed at 90% utilization with your storage system for an AI training job? So it's a very important hint for a customer, for example, that would want to know how many appliances do I need given the number of GPUs I have.
Yeah.
So it translates directly into GPU utilization.
Yeah, I did not know that about the MLPerf, so I appreciate the insight. And you're right. This was the latest one we just did was MLPerf 2.0. So started at 1, then I think 1.5, then 2. And it's a yearly thing, correct?
Yes, correct. It's a yearly thing.
So like I said, it's pretty new. But the fact that it's simulating AI workloads, which obviously is very top of mind for a lot of folks out there in the world, whether you're part of enterprise or sovereign AI or any one of the various industries out there like financial services and life sciences and automotive, to be able to simulate these AI workloads using real AI tools to see kind of what you need and what you can get there. Joel, did you have anything you wanted to mention about the MLPerf at a high level?
Yeah, so I think there's two very important things that Louis brought up. The first one is that saturation rate. So one of the things that customers have told us again and again, and it's not just customers, right? It's even guys in labs. They're saying they struggle to find out to get the most out of their GPUs. Many times they're sitting there going, we're lucky if we can get the thing saturated to 50% of its time. And if you're spending, tens or hundreds of thousands of dollars, whether you're renting them in a cloud, whether you are on-prem have purchased, NVIDIA or in some cases AMD GPUs, for the most part, you want to make sure that those GPUs are absolutely saturated. Otherwise, you're basically having to buy twice as many of them to get the same result. So showcasing what that 90% saturation level is a really big thing. And so when it measures it out, it talks about here are the number of GPUs that are saturated at that 90% rate concurrently. So it's all about the parallelism of getting all that data out for training. If your model is spread across multiple GPUs, et cetera, here's how you can get that massive level of performance. The second thing is that it's not just the frameworks, right? So Lou was talking about you have PyTorch and things like that, but the actual workloads that are run on top of that, things like CosmoFlow, things like ResNet, which are traditional like image management and image training types of platforms. These are the types of tools that are in real use by customers. They're the ones that NVIDIA has used to test their own suite of tools internally. And so if you're able to get scores on those actual application level of AI on top of the framework, that's a really good indicator of what you'll get for a variety of real world AI training functions.
And yeah, absolutely. And to your point about the GPU utilization, I think that's very important to just remind the listeners is that, when people think about AI, they know they need compute, they know they need GPUs, right? And they're spending hundreds of thousands, even millions of dollars on them. But what really is the facilitator of being able to saturate them and get the max usage out of them is the actual infrastructure layer underneath, the storage, the data platform, whatever terminology you're using, where DDN it plays, right? So it's very important that when you're building out your AI infrastructure, the storage piece or the data platform piece, whichever you want to call it, where DDN is that's our bread and butter. That is actually what helps facilitate that saturation and enables you to get to 90+% saturation of the GPUs due to all the various feature functionality that is included inside of that data platform. So it's very important when you're planning out your AI infrastructure, you're trying to fine tune your AI infrastructure, that you do look at that data platform, data layer, storage layer, because that is really the place where you can gain a lot of these efficiencies.
Absolutely.
Yeah. So Louis, I know that MLPerf, they take a very, how do I say, like, agnostic approach. It's not necessarily super competitive where they're comparing companies versus each other with like a 1, 2, 3, 4, 5, 6, 7, 8 ranking. They try and keep it a little bit more factual. So how did DDN do in MLPerf 2.0? What are some of the highlights that you can share with the audience in how DDN performed in this latest benchmark?
So we submitted in so there are multiple, as you mentioned. The numbers can be a little difficult to interpret, and this is why this year they added a new unit, which is the size of the system that was used. And this number is useful because it helps you normalize all the results you have. So if you go on the MLPerf storage website, you would see a table with all the number of GPUs simulated per system. But thanks to this number, we could normalize all of these results by the size of the system used. And when we do that, this is where we can see the efficiency of DDN systems. So for example, we submitted results in the single node category. And in this category, for both Cosmo Flow and ResNet 50, we achieved the best performance density. Which means pretty much that we achieve the highest number of simulated GPUs given a specific size. And it really shows like the dedication we have to make these systems efficient. And we are not just creating things that would scale if you had a huge cluster. Here, we really show off that this system works at any scale. Even if you have just a small number of nodes, you get the best efficiency achievable. So we achieved the best numbers for both in terms of density for both Cosmo Flow and ResNet 50. And these two workloads are much more difficult than ResNet 50. So it shows also that we have a good latency because these workloads are not FIO or IOR. These are real AI workloads where you need to have a good latency. You do not just need to deliver a good throughput.
Yeah, I think I remember Sven, our CTO, during talking to our Beyond Artificial launch back in February about IOPS and throughput are important, but when you talk about AI workloads, latency is actually very important, and time to first byte, which is a part of all of that. So it's great to see the results from DDN in that area because obviously customers are using us for AI workloads. So super duper critical.
So Louis, sorry if I may interject. So Louis,
Yeah.
a quick question for you. When you normalize this size of system, I think they normalize it by rack units, correct?
Exactly, yeah.
Yeah, and so I think performance density. I just want to make sure it was absolutely clear because performance density actually means a lot to customers moving forward, whether they're cloud NCPs, et cetera, or on-prem. One of the, for a while people have been talking about it's the token economy, right? And that's how we're defining, building these AI factories and everything else. But the other thing that's coming up is it's also the literally watts category. It's the watts economy, meaning there is limited power. When people are building data centers now, the first thing they do is they have to hunt down and reserve power from a local energy provider. Otherwise, they literally cannot build the space to put in these systems. And so if you're able to get higher performance density to maintain saturation and get a smaller footprint, every one of those watts begins to count, right? The DDN single 2U system, I think that we used is a total of 2,400 watts maximum, if I saw the note on it correctly. And so instead of having to put a stack of 6, 10, 20 nodes together, or in some cases, an entire rack together to get a result that may cost you, 20 kilowatts, we're really, really high density while maintaining all the goodness that you've seen from the DDN software stack within our environment. So I think it's really important to mention that power and footprint is becoming a really big consideration for a lot of customers.
Yeah, 1000%. I was going to mention that, Joel. Thank you for bringing that up. We talked to a lot of business decision makers, and they obviously want to see great ROI and low TCO on their investments in the AI space. And you're right. It's just a footprint issue inside data centers. Companies have to build brand new ones, and they need to find a place to do it because the existing ones are all full. And I've heard also that even the ones that are empty are full because all the space has already been reserved by companies who have these AI projects that they want to get to in a few years. They already have reserved the space. So, and of course, the impact to our environment and sustainability is always top of mind at the C-suite level. So if you're able to maximize the GPUs from a saturation standpoint in a smaller footprint that has less power, less cooling, less data center space cost, then I mean, that sounds like a home run in my opinion.
Yeah.
So we're almost at the end of our time, but we did get a few questions from the audience while we were chatting, and we touched on this question a little bit earlier at the very beginning, but I think it's important to talk about again. And the question was, can companies massage the numbers to make them look better for these benchmarks? We know that they can do it outside the benchmarking, right? We, of course, but we've got this finely high-tuned system, that we did internally. Like okay, like I'm a marketing guy, I've done that before, I know, but for the benchmark specifically, is there any massaging going on, or can you guys just talk about that?
Yeah, look, so every company puts their best foot forward, right? No one wants to go out there and put something that is crap out there, because then no one will take them seriously, or it'll be a result that just isn't relevant to the market, right?
Yeah.
So yeah, there's always a little bit of work. There's some tuning that always happens. Sometimes it's pretty minimal. I think we did very little tuning, other than just to set a couple of parameters inside of our system when we set it for these various benchmarks. But the reality is that everyone will try and promote the goodness out of it. So that's why going back to that transparency around how was the system built, what were the parameters, right, is really important. The production category is getting much better, and I hope to see even bigger improvements in terms of that transparency that they have and the disclosures. There are other benchmarks out there as well. There's Spec has one. There's another one in the financial services industry called Stack, which I think DDN has a couple of pretty good results in there. The Stack M3 benchmarks. And those are insane levels of verification, because if you look at those, you actually have to hand your system over to the benchmarking organization, and they run their suite of tools for you. Yeah, and so there is no out. They do a huge amount of disclosure that is built into their very standardized report. And so things like that, you can really get behind and say, yes, this is a very good. There wasn't a lot of massaging. If there was, it's exposed every time. And so I'm really glad to see, like I said, that in only 2 years, things like IO500 have really moved forward. MLPerf is beginning to add more and more levels of detail. So I think that's a win for everyone. The cleaner you are about it, the clearer you are about it, it serves everyone's interest a lot better.
I agree. I definitely agree. Well, that's all the time we have for today on our Ask the Experts Roundtable. I want to give a huge thank you and shout out to Joel and Louis for joining us and sharing a lot of great knowledge with us as well. And of course, this is a series, so we'll be doing a 4th one soon. So stay tuned, and looking forward to seeing everyone again. So Joel, Louis, thank you so much, and really appreciate the time.